For this problem, I need to get it into the form m dx plus n dy is equal to 0. To do this, I'll multiply all the terms in the equation by dy. We'll get x squared y cubed minus 1 over 1 plus 9x squared times dx plus x cubed y squared dy is equal to 0. Our m term is going to be the coefficient of dx, which is x squared y cubed minus 1 over 1 plus 9x squared. And our n term is the coefficient of dy, which is x cubed y squared. We can take the partial derivative of m with respect to y. This first term will give us 3x squared y squared. The second term has no y, so it'll be 0. We'll also take the partial derivative of n with respect to x, which will also be 3x squared y squared. Because these two are the same, we know that this equation is exact. We can now take the integral of m with respect to x. So we'll take the integral of x squared y cubed minus 1 over 1 plus 9x squared, all with respect to x. This first term will be x cubed y cubed over 3. For the second term, I'll factor a 9 out of the bottom. So we'll have 1/9 times 1 over 1/9 plus x squared. We can use the arctangent formula for this. It'll be 1/9 times 1 over 1/3 times arctangent of x over 1 over 1/3, which will be negative 3 over 9 times arctangent of 3x, which will be negative 1/3 arctangent of 3x. I'll bring this first term, x cubed y cubed over 3, down here, so it'll be x cubed y cubed over 3 minus 1/3 arctangent of 3x plus g of y. So this is our function. We can now take the partial derivative of this function with respect to y, which is definitionally equal to n. And we said n is x cubed y squared. That'll be equal to the partial derivative of the function, which will be x cubed y squared. This arctangent term will be 0. It'll be plus g prime of y. These x cubed y squared terms will cancel, and we'll get that g prime of y is equal to 0. We can integrate both sides with respect to y, and we'll find that g of y is equal to 0. So we can now write this function as x cubed y cubed over 3 minus 1/3 arctangent of 3x is equal to c. And that is our final answer. If this video helped you, consider subscribing.